Welcome to the Nokia SR Linux Learning Essentials video series, brought to you by the Nokia Data Center Fabric Certification Program. This video explains a special type of access control lists called CPM filters to filter network traffic destined for the control plane. An ACL is a kind of filter with a set of ordered rules. When an ACL is applied to an interface, the system will check every incoming or outgoing packet on that interface against the set of rules. Match criteria are based on various protocol frame header fields. When the packet matches a rule, the associated action is executed. This action can be either accept or drop, which means the packet is blocked. Additionally, matching packets can also be logged for further analysis. There are some special access control lists that work only on control packets terminating on the router. They are called CPM filters. They are similar to regular ACLs, but can also rate limit these matching control packets. SR Linux also supports another type of ACL called the capture filter. It lets you analyze matching packets in a similar way to the Linux TCP dump tool. In this video, we will only cover CPM filters, which apply to packets terminating on the router's control processing module. Up to 3 CPM filters can be configured, one for IPv4, one for IPv6, and one for non-IP packets. Like an ACL, a CPM filter consists of multiple entries, each with a match criterion and an action to accept or drop packets. The CPM filter can also control the rate at which matching packets are received. This is typically used as a security mechanism against denial of service attacks. Also note the order of evaluation. The CPM filters only apply after the system and the ingress filters, so packets that are dropped on an ingress interface will not be evaluated by the CPM filter. We are going to implement a CPM filter in the Nokia My Learning Lab platform now. The lab topology consists of a leaf and spine data center with 2 leaf routers connected to 2 spine routers. The network is already configured so that hosts connected to leaf 1 and leaf 2 can communicate with each other. We also have an out-of-band management network that the DC administrator uses to connect to each router. A typical CPM filter use case is to allow certain type of applications, for example SSH from only trusted networks, like our management network here. So a user, here from the management network, can connect to leaf 1. But anyone else, such as a user on any of the connected hosts, here in red, will be prevented from doing that. Okay, let's see how this filter works in our proposed lab. We can connect via SSH to the different routers and hosts in our lab using the tabs on the top. Let's go on leaf 1. The CPM filter is already configured, but has not been committed yet. Now under the ACL branch, we can see the ACL filter with name CPM and type IPv4. Entry 10 accepts SSH traffic received from our allowed management network, and entry 20 drops all other SSH traffic. This CPM filter must then be applied to the control plane interface. This is done under the system control plane traffic branch. This is the uncommitted candidate configuration, so the CPM filter is not activated yet. Let's go to host 10 and try to SSH to leaf 1's loopback IP address. It asks for a password, so we know that leaf 1 is allowed. We can also SSH to the interface IP address of leaf 1. It works as well, but it's not secured. Now let's go back to leaf 1 and commit the CPM filter. We go again to host 10, and we try to connect to leaf 1. This time, the SSH fails. Same thing for the interface IP address. It fails as well. The CPM filter works as it should be. We can no longer log onto leaf 1 from host 10 because host 10 does not belong to our trusted management network. Statistics can be enabled by setting statistics per entry to true. Once enabled, we can get the number of hits for each CPM filter entry as well as the last match time. The show command also displays the number of TCAM entries. CPM filters are implemented in hardware in a dedicated memory chip called TCAM. TCAM stands for Ternary Content Addressable Memory that is present on every line card. TCAM's entries are limited, so it's important to track how many are required for each CPM filter. Another feature that we like to discuss in this video is the CPM rate limiting. As mentioned earlier, the rate limit action is typically used to prevent denial of service attacks. As an example, a malicious user could send thousands of HTTP requests to consume router resources and block legitimate requests. SR Linux supports rate limiting at 2 levels. Traffic goes first through a hardware-based rate limiter, the distributed policer, implemented on each line card, and then through the software-based system CPU policer, running on the CPM. This hierarchical policing ensures that traffic coming in on one line card does not starve the resources for all other line cards. Both levels of policing can be configured with a max burst size and a peak rate parameter. If the rate of the incoming traffic exceeds the peak rate, packets start to be queued and then get dropped when the burst size is reached. CPM filters are an essential security component that should be implemented on every network equipment. By default, SR Linux comes with a CPM filter with dozens of entries, of which just 2 are displayed here. But it would include applications or protocols such as DHCP, OSPF, and BGP. These entries should be customized just like you would change the default factory admin password. Nokia recommends implementing a strict CPM filter, which allows only protocols and applications that are used and traffic that is coming only from trusted sources. Everything else should be dropped and optionally logged to trace rejected traffic flows. Configuration mistakes may happen, but a mistake in a CPM filter can have big consequences. As an example, imagine you are connected to a router and you implement a CPM filter but forget to add your own subnet to the trusted source IP prefix. You'll be kicked out of the router as soon as you commit your config. To prevent this kind of accidents, you can use the commit confirm option. When you commit confirm a configuration change, the new config is applied immediately, as usual, but the system will start a confirmation timer, which is 10 minutes by default. If you do not confirm within this time frame, SR Linux will automatically roll back to the previous configuration just before the commit. This way, you will just have to wait for 10 minutes, then log in again and fix the faulty configuration. That's it for SR Linux CPM filters. Thanks for watching, and be sure to explore the rest of this video series to learn more. And when you're ready to practice what you've learned, my DCF Learning Labs provides comprehensive exercises with step-by-step instructions and solutions, all in one simple browser-based application.